All right, we're going to continue then, now that we've looked at nested if statements, to look at some things that can happen with programming, and then we'll look at some other example programs. So first thing I want to talk about are logical operators. And logical operators are ways of dealing with true or false. So we have not, which is an exclamation point, that negates the truth or falsity of a statement. So if the statement is true, we can read this as not true or not false. And is a conjunction. And means that both sides of the operator should be true. Or is a disjunction, which means that either side can be true, including both. And then the caret, the pipe or here, and then the caret or, which is an exclusive or, also known as an XOR. One side has to be true, but not the other. So I'm going to draw some logic tables for these, and we can look at how these get applied. So let's come over here and give ourselves a logic table. So when dealing with logic, we tend to use the variables P, Q, R, S, and T. We use this part of the alphabet. Mainly P and Q get used a lot because logical operators tend to start with two premises. And these variables can either be true or false. And so we can make a logic table where I write all the possible values of the P variable. And if we look at the operator not P, we can look at all the resulting values. So P has two options. It can be true or false. And the not operator on it changes trues to falses and falses to true. The AND operator takes two sides. So I'm going to need two variables, P and Q. Whoops. And what I'm going to try to look at is what happens when we get the operation of P and Q. So we have to look at all the possible values of P and Q. So P can be true, Q can be true. P can be true, Q can be false. P can be false, Q can be true. P can be false, Q can be false. And so that gives us every possible combinations. P and Q is only true if they're both true. So that's true. That's false. That's false. And that's false. And so this is the effect of the logical operator AND. Give them their English names here. Let's do a similar thing with a truth table for the OR operation. So I'll draw my columns here. And I can have P, Q, P, or Q. And this is OR. Again, P can be true, Q can be true, P can be true, Q can be false. P can be false, Q can be true. P can be false, Q can be false. Well, if this needs one of them to be true, then that's true. That's true. That's true. And that's false. But the English language has a different type of OR when we do either this or that. So let me scroll down here. And let's look at the exclusive OR, XOR, and its truth tables. So we're going to have P, Q, P exclusive OR Q. And this is the shift 6 on the keyboard. Again, P can be true, Q can be true. P can be true with Q being false. P can be false with Q being true. And P can be false with Q being false. And so exclusive OR needs one and only one true. So that's false, that's true, and that's false. And that's how the exclusive OR. And so truth tables are a good way sometimes when you're combining things. I want P and not Q or R. You can sometimes put statements together like this, depending on the logic that you're trying to create. We'll see some ands and ors for the time being, but these other logic operations will come up, and we'll introduce usages of them as we go about. And what we want to look at then next is the singular operators. And so we can have a singular and a singular or. And these are very particular operators within computer programming. And what we can do is we can look at a singular. And so the book's doing here is going to ask us to look at what the singular and an or do. So we're going to type in these examples and see what happens to x after the expression. So if x is greater than 1 and we increment x to be less than 10, and we'll compare it to this expression here. So we'll go back into Eclipse and we'll create another sandbox here. In fact, I think I will just open up my sandbox since this is a good place to play with code, and we'll delete any code that was in the sandbox previously. And so we use this as a starting point to look at the bitwise operations. All right, so we're going to look at bitwise operations. And the bitwise and an or combine things on a bit-by-bit nature. This can be faster, and you can use it sometimes to create what I call flags. Let me draw this first, and we'll come into the sandbox here. Let me clear what's on my blackboard here. Clear. So let's say we're looking at a integer number, or an integer. We're going to look at the integer 3 in binary. So for the 2 to the 0 bit, it has a 1. And for the 2 to the second bit, or 2 to the first bit, it has a 1. So it has a 1 and a 2. So this is the integer 3. And then all the rest of the bytes are 0. And I'm just going to use an 8-bit representation here. And let's say I want to compare it with, well, if I'm using an 8-bit comparison here, then an 2 to the 8th is, let me do my powers of 2 here. 2 to the first is 2, second 4, cubed 8, fourth 16 as I use my doubling laws, 32, 64, 128. And then in the 8th bit is our sign bit for sign. So we'll ignore what's going in here for right now. And so let's say we want to compare the integer 3, which is the first 2 bits turned on, to the number that has all the rest of the bits turned on. And so this is 2 to the 8th minus 1, or it's the integer for 255. So we want to compare these numbers. And if we AND the numbers, wherever they're both 1s, you would get a 1 back out. And for all these, you'd get a 0 back out. And so the AND operation would give you an answer of 3. If I OR all these bits, well, there's a true everywhere. And I would get a 255 back out. And so the single pipes I can never do an AND properly. I have to look at it on the keyboard. You come up, over, and back out for AND. And the single pipe for OR work on a bit basis. Now, built into the CPU of the chip, this is actually quicker comparisons. And so a lot of times I'll let bits represent the state of something. So, for example, is this a picture is the first bit? And so I can do a bit comparison and see if I have a value. I could do 0, 0, 0, 0, 0, 1. And if I AND that with my number, I would get the number 1 back out. And I know that the picture frame is turned on in this particular version. And so by selecting individual bits, you get a faster run on the CPU for comparisons. Now, Appendix G has a list of these in them. So let's look at Appendix G here. And let me see if I can get that in the proper place here. So here's Appendix G. It's cut off a little bit. My apologies. Let me fix that. There we go. And I'll scroll that in properly. So in Appendix G, they list bitwise operators. And machine level code deals with binary numbers directly. Java provides bitwise operators, and it has this table of bitwise operators. Now, they only apply to byte, short, integer, and long, as we can see down here. Character involved in a bit operator is converted to an integer. So if I give it the letter A, it will turn the letter A into its numerical value. And we can also do bitwise assignments. I can assign an OR equals. So if I have I and I'm ORing it with something. But what happens is that if we look at the bit representation and I AND it with another bit representation, wherever there's 1s in both of them, so there's a 0 and a 0. When I AND them, I get a 0 back. Again, these operations run a little bit faster, and for things that have multiple states, common to use called bit flags or flag systems. So let's just look at how these are used in Java a little bit, or at least look at the output from them. They're a unique programming tool. So I'm going to use the example I used. I'm going to set an integer. So I'm going to have an integer a equals 3. And then what I'm going to do is I'm just going to print out the result of a bitwise operation on it. And so I'm going to do a or 255. And if we flip back to my drawing here, A is all of these zeros, and 255 will all be 1s. And so if I OR it, all the zeros and 1s, the OR of a 0 and 1, if we think of these as true or false, will be 1s. And so if I OR this operation, I should get a 255 back. And I do. I get a 255. But if I look at the AND of the operation, well, the only thing that both of these have is in the bits for the 3 value, and I do get a 3 back. So the reason I show this right now is there's certain switches and things that people do in their programs where it might be more efficient to use. Oh, and my eclipse didn't show, so let me show this again. My apologies on that. This hit a button and it doesn't always flip over. So if I OR this system, I get a 255 back. And that is exactly like ORing the 000000011 with the 111111. And because there's a truth in every value, I get a 111111 or a 255 back. And so that's how the OR works. If I change it to an AND, and run it, I get a 3 back. And this is because when I AND something, only where they're both ones do I get bit values back. 1, 1, and then because these aren't both ones, I get zeros back, and that's the same as integer 3. And so you can AND something with a particular bit flag. So if I were thinking each flag, let me go to my eclipse, and I'm just going to focus on the first 3 bits. So I'm going to have some integer. So the first 3 bits are 0 or 1, 0 or 2, or 0 or 4. So the numbers, if all of those were on, I would get a 7. So let's make a 7. And now I want to see if only the 4 is on. And so the 4 would be looking to see if the third bit is turned on. So if I AND this, I do get a 4 back because in the 7, the 4th bit is turned on. Let's look at that in our CREDA view here. And so what I was saying was I put in a 7, which had these 3 bits on. 2 to the 0th, 2 to the 1st, 2 to the 2nd. And I asked an AND of was this bit turned on because I asked 4. Now I could ask if the 2nd bit was turned on. Let me put the numbers that these represent over here. By ANDing it with a 2, or I could AND it with a 1. Now, if, let's say, I only turned on, let's say I only turned on the first and the last bit, so the first bit would be a 1 and the last bit would be a 4, that would be a 5. And so if I AND this to see if the 4th bit is turned on, whoops, not the 5, 6. 6 and the, so 4, 5, let's see, or not the 4th bit. I have to draw this out now in my head. The 2nd bit is on, which is a 2. So let's say I have 4 turned on and 2 turned off and 1 turned on. Now I'll check if 2 is turned on. And it isn't. I get a 0. This is a good thing to start practicing now. I will have one problem that I'll ask you to do bitwise operators, and we're going to focus on AND and OR to start with. It's a concept that isn't as used as much in modern computing, but again, my warning I give to everyone is large data sets take very long periods of time to run, so anything that can be a little more faster or efficient on the modern large data set, it's a helpful piece of knowledge. And the other thing to look at for the CS majors that, let me get over to the browser here, that will be working with discrete mathematics, you will be able to use the exclusive OR, the ones complement, which flips the bits to other sides, and then we can do left shift and right shift, which moves the bytes or the bits over by one, adding a 0 in to the left. So it moves everything to the left by one, and in this case by 2 bits separated. And here we right shift by 2 bits. And you can build addition and subtraction and do multiplication with bit shifting. Again, the CPUs are built in to run around these bit comparisons. So it's good to know a little bit what the CPU is doing on the inside. All right, let's get back past bit operators and the outputs from bit operators. Whoops, that is the wrong thing to hit. We'll come back here. And what we're going to do is we're going to look at one last thing, which is a couple last things, and that's the switch statement. A switch statement takes a logical value, and the value that's in here will have cases. So let's say it is a number 3, 4, 5, or 6. In this case, it is the number 0, 1, 2, or 3, and then run the default. And so it'll do what's in case 1. Then you have to hit break so it jumps out. You do what's in case 0, case 1. So you can have some switching statement that relays to different outputs, and then based off of the value in the switching statement, you run some code. It will continue to run down all of these and hit the default. Break is a command in Java that breaks us out of the braces that we're in. So in this, they're looking at how tax statements are filed, where if you're a single file, you will do one action. If you're married jointly or qualifying widow, that's status 1. Married filing separately and head of household, these are each default different actions. And notice when you break, it comes out of the braces. So if we go back up here and look at this, here are the braces that we're defining this. The break takes you out of the braces. And so switch statements work their way through a list of values. So the switch expression must yield some value of a character or something that is an integer in type, integer short bytes. And that must always be in parentheses. Then in the cases are the individual values, and these values must be the same data type up here. So you can process characters with cases. And then when you get all the way down to the default statement, which is optional, will perform an action if you fall all the way through this entire list and never hit anything. The break is optional, but it should be used so that the program doesn't have to run through everything in the switch statement. So let's look at a switch statement up close. Here we're going to ask, is the day 2? And so if the day is 2, it's going to do whatever case 2 says. So it matches case 2. It falls through to case 3 because there's nothing in case 2. Falls through to case 4 because there's nothing in case 4. And it falls through to case 5. It will print system.out.print weekday and then enter the break. Otherwise, the 0 and the 6 will print weekend. And so a switch statement is a statement that can let us do multiple categorize data based off of some common identifiers. In fact, the days of the week being a mod 7, right? Remainder division 7 gives us 0, 1 through 6. This program here will classify the days of the week if it is a weekday or a weekend. And that's the example program I'm going to look at afterwards. And so I'm going to pause this video here, and we're going to look at a days of a week switch statement.